All right, so they give us f of t, and they want to know for what value of t is, and here we go, f prime of t. So I know that I'm going to have to take the derivative of this, and I'm going to set it equal to, because it says equal to, and then it says average rate of change. So what I'm going to do is I'm going to take the derivative of f and set it equal to the average rate of change. Now let's see if you remember what the average rate of change is. Remember, average rate of change is f of b minus f of a over b minus a. Okay. All right, so let's start with f prime of t. Well, I know that f of t is really t to the negative first power, right? So let's take the derivative of that, and that's going to be negative t to the negative second power. Okay, let's just go one extra step further. So f prime of x is equal to negative 1 over t squared. Okay, so let's leave that aside for a moment, and let's figure out f of b minus f of a. Well, f of b would be taking my f of t equation, and I'm going to be plugging in b here. And then f of a would be the same f of t equation and plugging in a there. So that's going to give me 1 over b minus 1 over a, and then that whole thing is over b minus a. All right, so let's find a common denominator. So I'm going to multiply the first fraction by a, and I'm going to multiply the second fraction by b. And then that's going to give me a minus b over ab, and that is all over b minus a over 1. So I'm going to keep change flip, bring this up, and that's going to be 1 over b minus a. And remember, that cancels out. Okay, now let's also take note that these guys right here are opposites of each other. So remember, you can actually cancel those out as long as you multiply by a negative 1. So this is gone and this is gone, and I'm just going to put a negative 1 up here. Okay? All right, so then that is going to give us negative 1 in the numerator and ab in the denominator. Okay, so now let's remember that we are setting, and let me put this in a different color so we can see a little bit better. We are going to be setting f of b minus f of a over b minus a. That's what this is. And we're going to be setting it equal to f prime. All right, so I've got negative 1 over t squared, and I'm going to be setting that equal to negative 1 over ab. Well, I can get rid of the negatives, and I'm just going to cross multiply. So I essentially have t squared equals ab, which then means t is equal to the square root of ab. And there's my answer, and my answer is choice B. Okay, so they give you a chart, and they would like you to do 10 subintervals of equal length, and they want us to do the trapezoidal rules. So 10 subintervals would mean this one with this one, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm just warning you, I am not doing all of these. But trapezoidal rules, so let's figure out the area of a trapezoid. Trapezoid is 1/2 height, and then base 1 plus base 2. Okay, so I'll do the first few for you, and then I know that you can finish off the rest, and we just keep adding each time. So if we look here, remember that this value here, the distance between your x's, is actually your height. And then we've got base 1 and base 2. Okay, if you're unsure, remember you can always plot these points. It doesn't have to be totally exact. Just gives you a general idea, like a picture, so that you can see it a little bit better. Okay, So that being the case, the height, if you look here, is 1. The height here is 1, 1, 1, so on and so on. So my height here is always going to be a 1. So it's only my bases that are going to change. Okay, so then let's look at it, and let's start writing that down. So 1/2, my height is always going to be 1, which I really don't need to write that, but anyway. Okay, so I'm actually going to leave those on the outside, and I'm going to do the first set of bases. So I have 20 plus 19.5. Okay, so that would be this trapezoid right here. Okay, now I'm going to do the next trapezoid. Remember, the next trapezoid will be these two guys right here. We overlap this guy from the first trapezoid to the second trapezoid. Okay, so then I'm just going to write plus. All right, so my second trapezoid's 2 bases. The first one's 19.5, and then the second one is 18. Plus, now I'm going to do the third one. So I'm going to repeat again. So this was my first trapezoid. Those are the 2 bases. Now I've got my second trapezoid. These are the 2 bases. Now I'm going to go to my third one. This will be my third trapezoid. These are the 2 bases. So this guy overlaps. Okay. All right. So then I've got 18 plus, and then what do we have here? 15.5, right? Okay, and you're just going to keep adding so on and so on and so on until you get to the end, which would be these 2 guys added. And yes, you keep them negative, that's fine. Okay, so when all is said and done, and you add all of that up, now remember you have a calculator for this section. Let me repeat, 31, actually, let me just double check for you. 29. Woohoo. 29 to 45 is calculator, so go ahead and use a calculator for this. Okay, if you want to turn me off and work it out and then come back and you'll get an answer, that's fine. Don't forget though, when you finally add everything up, you have to multiply by 1/2 or divide by 2. Okay? All right, and the answer, oops, let me put that back there. My answer is going to be B, which is choice B, which is 32.5. Okay? All right, this is really just a reading and a thinking question. So basically what they're telling you is R represents the rate at which water is leaking out. And then it says, which of the following represents the total amount? Now listen, when we go from a rate to a total amount, we're integrating. Okay, and so so that's going to cross off choice A and choice B, and so we need to be integrating, but in this case, we are integrating, let me see, represents the rate at which water is leaking out, and here we have the total amount of water that leaks out. So we are integrating our R. Okay, so that would be choice C, because it also says in the first 3 hours. Okay, so then our answer is going to be choice C. Okay, so the question's asking for h prime of 1. I'm going to start with finding h prime of x, so let's do that first. So we got a little bit of chain rule here. So I take the derivative of f and leave the g of x. Then I take the g prime of x. Think of it this way, and this is the way I've always tried to get you to look at this. Think of it as if they were asking for the derivative of the sine of 2x. So what you would do first, right, is take the derivative of sine, which is cosine, and then you take the derivative of the 2x, which would be 2. So that's what I just did here, okay? So I here's where I'm taking the derivative of the sine of 2x. That's like my cosine of 2x up here, okay? And then this g prime of x is like the 2 right there, okay? All right, so then I'm just going to plug in 1 now, and let's see how we do. So h prime of 1 is equal to f prime of g of 1, and then times g prime of x. All right, so we're going to do this in a couple of steps because I'm just going to bring down that f prime and let me figure out what g of 1 is. So I'm going to go up, look up at the top there, and g of 1 is 3. So what that means now is in my next step, I'm not going to do it yet, but I will be evaluating f prime of 3 in a minute. Okay, so let me figure out, though, g prime, oops, that should be a 1, right? G prime of 1, and if I go up and I look at that, that is going to be, what, -3, right? Okay, so let's go a step further here. I'm going to do f prime of 3. So f prime of 3 is -5 times that -3, which is going to be +15, which is choice B. Okay, I would take a few minutes and really read this question through and probably go through it a few times. Okay, so if you need to, pause me. Now, the one thing it does say is that it does say that B is 1,000 feet horizontally from A and 100 feet higher. So what that really gives you is the coordinates of B. Okay, so B is 1,000, comma, 100. Okay, so we've got an x value and a y value. The other important thing it tells you is that r prime is continuous. So that means I can look at this, take its derivative, and I can set the top part of the piecewise function equal to the bottom part of the piecewise function. So let's look at that. So if I do r prime of x, I'm just going to take the derivative of each part. So then if I take the derivative of the top part of the piecewise function, I get 2ax. And if I take the derivative of the bottom, I'm just going to get b, right? Now, it says that the derivative is continuous. So that means that these two guys should be equal to each other. So 2ax equals b. And it wants me to solve for b. So I obviously have to know what a is, and I have to know what x is, right? Okay, well, I do know what x is, because if we look up here, they gave me an x value, right? This is x, and this is y. So I can plug that in for my x value. So 2, I'm still not sure on that a, but I know that my x is 1,000, right? So if I could just figure out what that a is, I'm all set, right? So this gives me 2,000a equals b. All right, so there's got to be a way to find that a, isn't there? Well, let's go up here, and I notice that in my piecewise function, the original function, I have, this is essentially y equals, and the top part of the piecewise function has an a in it, right? So this is really y equals ax squared. Don't I know what y is? It's 100. And don't I know what x is? It's 1,000. So I can solve for my a and then plug it right in here. Okay? All right, so just in case you kind of were following, but not totally, here we go. So again, I'm going to put this off to the side. So I know that y is equal to ax squared, right? Okay, now I know the y value. They gave it to me. It's 100. And I know the x value is 1,000. Okay, now remember this is a calculator question. So that's squared, right? So you put that into your calculator, and you're going to end up with a equals 1 over 10,000. All right, well, there it is. We just solved it, believe it or not, because we're going to take that, and we're going to put that right in here. So I have 2,000 times 1 over 10,000, and that is what b equals. Okay, just do a little bit of fancy footwork there, and I'm going to get 1/5 is b. And that is what answer choice A. Okay, so they want the area of the region enclosed by those two graphs. So just take your calculator, and you're going to plug them into your y1 and your y2. You're going to get a picture like this, and this one is your y equals let's try that again. Y equals e to the x squared minus 2. And that should be a big 2, right? And then your square root is going to look something like this. And that'll be your y equals the square root of 4 minus x squared. Okay, so you're going to do second calc intersect. And you're going to find this intersection point here. And I'm just going to use the x value. So I have x equals negative 1.1372. And then over here, I'm going to do second calc intersect. And again, I'm just going to use the x values because I'm going to do this with respect to x. So that's x equals positive 1.1372. All right, so then remember when we want to find the area, what we do is we integrate from negative 1.1372 up to positive 1.1372. And then remember that we're trying to find the area of this enclosed region. So remember it's top curve minus bottom curve. So my top curve is the square root. So 4 minus x squared minus the bottom curve, which is e to the x squared minus 2 dx. I'll squeeze that in there. All right, so then remember when you're doing this in your calculator, okay, so I'm taking out my calculator right now as I speak. You should already have the equations in your y1 and your y2. So remember you're going to hit math. You're going to go down to number 9, fn int, and then you just plug everything in, okay? So remember if your radical equation is in your y1, you do the vars, y vars, enter, enter, and so on and so forth, okay? All right, so A equals 5.0495, which is choice D. Okay, so let's be a little careful with this question. It's not a hard question, really, but there's one little trick that we really haven't spoken that much about. So I'll explain it to you now. So they're giving you a table for the acceleration, but they are asking you for an approximate value of the velocity here. So you know that to get from acceleration to velocity that we have to integrate. And they're telling you to use a Riemann sum with 4 subintervals. They don't tell you which kind of Riemann sum to use. So to be completely honest with you, it doesn't matter. So you can do a left Riemann sum, you can do a right Riemann sum. It really doesn't matter which way you go. I've done it both ways, you're going to get the same answer. So 4 subintervals, so I would go like this, like this, like this, and like this. Okay, so again, if I want to find the velocity, I'm integrating the acceleration, which is basically finding the area under the curve, again using Riemann sums. Now if you look at the 4 brackets that I just made, each width of those is 2. So the width of every rectangle that you're going to have is going to be 2, right? Okay. So then, if I was doing, let's say I was doing a left Riemann sum, then what I would do is I would look at my first interval here. I would say, this is the value on the left, between 0 and 2, right? This is my value that's on the left, and I would go to its y value, which would be 2. So 2 times 2. Plus, well, again, I know the width of the second interval is also 2. Then I would say, okay, between 2 and 4, this is the value that's on the left. Let's go down to its y value. So that means the height of that second bar would be 3. Plus 2 times, and do it again. So here's my next interval. 4 is the value that's on the left of that interval. I go to its y value, and that will determine the height of my next bar. Now remember, you can always draw a picture, so you can plot these points if it makes it easier for you. Okay, it's not necessary, but you can. All right, so then, lastly, let's look at the last interval. All right, 6 to 8. 6 is on the left, go up to its height. Its height is 3, so then 3 is the value that I'll be putting in here. Okay, so then you work that out, and you get 4 plus 6 plus 8 plus 6. Right? And if you do that, you get 24, and everybody thinks the answer is D, and it is not D. Because of one and this is where, we really haven't gone through this. Let's read what this says. I'm looking at the second sentence. It says, if the velocity at time 0 is 4 feet per second. That's like, I think we talked about, or maybe we haven't. So I'm going to repeat myself if I've already said it, and if I haven't, then I'll teach it to you now. If you are running a race with like a 4-year-old, I mean, that would be kind of mean for you to, run the race, true blue, you both start at the start line and you do, let's say, a lap around the track. Of course you're going to beat that 4-year-old because you have longer legs, you have more stamina, so on and so forth. So usually what we would do is we'd be kind of nice and we give that kid a head start, right? So the head start would probably, maybe we'd let them start halfway around the track and you start at the start line. So that's giving a kid a head start. So at time 0, this is what I call the head start. So at time 0, you've already had 4 feet. You've already gone 4 feet in a second. So you have 24 here plus this 4 feet, your head start, okay, which will give you a total of 28. And that is your answer. So that's like the little head start. We'll keep doing that and it'll sink in more every single time we do a question like this. Okay, so your answer is choice E. All right, so for this question, they're telling you that you have an even function. Remember that an even function is symmetric with respect to the y-axis. So I'm going to draw a little number line and I want to just show it to you. Some people can figure this out without this. I'm kind of a visual learner, so I'm going to do it this way. So they're telling me that the integral right here from 0 to 1 is 5. So if I have some picture and I look at the area under the curve from 0 to 1, that area is 5, right? So let me just kind of do it this way. So I'm not going to draw the picture, but the area underneath that curve from 0 to 1 is 5. So then wouldn't it make sense that if it's even, that the area from -1 to 0 would also be 5, right? Because even means it reflects over the line over the y-axis, and therefore it'd be the same amount of area, right, on the other side of the y-axis. So then I'm going to look at the second little bit of information that they give you. And if you look at what they give you, they tell you the integral from 0 to 7 is 1. So that means the area under the curve from 0 all the way out to, I'm just going to put a 7 here, all the way out to 7 is 1. Now, you might ask, well, how is that possible? But think about this. The area from 0 to 1 is 5, so maybe the picture kind of goes like this, whoop, like that. And then if the area from 0 to 7 is 1, that means that the curve would swoop down here and you'd have some negative area. Okay, which would then, you'd have a negative area of 4, wouldn't you? Because 5 plus my -4 would give me that 1 there, right? Okay. All right, so then likewise though, if that's the case from 0 to +7, then from -7 all the way out to 0, right? This would also have an area of 1. Okay, now let's read the question. So the question asks, what's the area under the curve from -7 to -1? So they want to know what's the area from here to here. Okay, so the answer would be choice B. It would be -4. Because like I just said over here, we'd have a space of -4 here, right? Because 5 plus -4 would give me that 1. So the same thing's going to hold over here. This 5 plus -4 will give me that 1. Okay, so the answer is choice B. So you have a graph of the derivative, and they're talking about points of inflection, which means second derivative. So you can do this two ways. We could make a sign chart of the second derivative. Now remember, if we're making a sign chart of the second derivative and we have a picture of the first derivative, we look for increasing, decreasing. Okay? So I'm going to look and I'm going to say, well, look, I start increasing till I get to this point. I really don't know where that is, and it doesn't really matter. You'll see why in a minute. But so I'm going to start increasing. So my first value here is going to be positive. Okay. Then if we look, we see, well, now I start decreasing till I get to whatever this point is. Okay. And then I start increasing, decreasing, increasing. So let me just throw those all on there. Okay, so I start decreasing, right? Then I start increasing just a little bit. Then I go decreasing again. And then I go increasing again. Okay? All right, so if you read the question, though, it doesn't ask for where there are point of inflections. It just says how many are there. So you can count points of inflection. Remember, second derivative changes sign. It doesn't matter what direction, like positive to negative or negative to positive. It just changes sign. So 1, 2, 3, 4. So the answer is choice E. Okay. 40 is asking for the average value. Remember, average value is the integral of a function. So in this case, the integral of f of x, and from this case from 0 to 12. But don't forget, then we divide by 12 minus 0. So we're going to find the integral of this function. We don't have an equation, but we do have a picture, so we're just going to find the area under the curve. So I see that I have myself a rectangle, so I'm just going to do base times height, and I know that the area here is 32, right? And then I have a quarter circle, so I'm going to be doing 1/4 pi, and then the radius, and if you look, that radius is 4, so radius squared, so that would be 16, right? All right, so then basically what I have is 32 plus 4 pi, and that whole thing is over 12. And then just put that in your calculator. Choice B it is. Okay, I know you're going to love me on this one. Skip 41. We're never going to do it. Okay, this one's a total calculator question. I'm going to go through this one kind of slowly because, again, I know you know how to do this, but we really haven't put something like this all together. So first of all, they're giving you an amount, okay? So an amount of a certain item is produced in a factory, and that's given by this equation. So remember that this represents an amount. Okay, so then they tell you that T stands for hours and the production since the beginning of the workday at 8 a.m. We'll go back to that. Now let's read the question. It says, at what time? So they're asking for T, which really, if you look at this, is like an X value, right? So at what time is the rate of production increasing most rapidly? So as soon as they put this word rate in there, you should think derivative. So you know that you're going to have to take the derivative of this. Not only do we want the derivative, though, we want to know where the derivative reaches a maximum because it says increasing most rapidly. So I'm going to repeat that again. Because of this word rate, that means derivative of this. So they want to know when the derivative is reaching a maximum. That's what that means. Remember, I told you calculus is a foreign language. Okay, this is a calculator question, so we are not going to be taking derivative, setting it equal, no. So we can do this in the calculator, and I don't know how much we actually did do this in the calculator. So I'm going to take some screenshots, and then I'm going to show you what to do. So here we go. I'd actually like you to start by plugging in the A of t into your y1, so do that. All right, so if you look at what I have in my y1 here, now there's a 4 under there. I'm sorry, my cursor was blinking at the moment. So here's what you should have plugged in, okay? Now, your calculator, we really only care about what the derivative picture looks like. So I did a couple things. So first things first, I went into my y2, and if you have to pause me, then I want you to pause me as we go along. And I hit n deriv. Remember, that's math 8. Because I'm going to take the derivative of this. I want the graph of the derivative of this. And I'm too lazy to do it myself, so the calculator will do it for me. So I hit n deriv, and it opened this up. And actually, I think you had a blinking box right here, and I just typed in x. So this is saying take the derivative of what's in my y1, and then it says at x equals what value? Well, they didn't give us an x value, so I just put an x there. Just go with me. What this is going to do is this is going to give me a graph of the second derivative. Okay? That's how we type that in. Now, the other thing I want you to notice is notice that my equal sign here doesn't have like a black box around it. If you don't do what I'm going to explain to you right now, it's fine. You're just going to see two graphs and you're going to have to ignore one of them. But if you go and you highlight this equal sign right now in your calculator and you hit enter, it's going to, and then if you move your cursor down here, you'll see that your equal sign isn't highlighted anymore, like mine isn't. And what that does is that allows you to not see this graph, because I don't really care about it. I only want to see this one. Okay? All right, now the other issue is if you hit a zoom 6 or whatever right now, you're not going to see this picture. And the reason why you're not is we're like at 4,000 here. That's kind of big. So the other thing that I'm going to do is I'm going to change my window. I'm going to take a picture of that and show you what that looks like, okay? So now you can see my window here. And so I went from 0 to 24 and a y min of negative 100 and a y max of positive 100. So maybe you want to pause me for a second, stop, put that in, and get yourself a nice, pretty picture, okay? All right, so when you do that, this is the picture that you should get. Oops, did it again, darn it. So this is the picture that you should see. Then you're just going to do second calc max. You know, go to the left, hit enter, go to the right, hit enter twice. I know you know how to do that. So that I don't really have to go over with you. Okay, so when you do that and you do second calc max, you're going to get x equals, now depending on where you put your cursor, you might get x equals 3 or you might get x equals 2.999999. It's x equals 3. Okay, this is what I want to talk about. Now that x really is a t value, it's time. So 3 represents how much time has elapsed. So that is 3 hours. But remember that we started at 8 a.m. So 3 hours elapsing would mean I would add, and I would have 11 a.m. as my final answer. Okay, so the answer is choice C. Wasn't that one fun? All right, so this one says at how many points on the curve of y equals blah, 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 will the line tangent, derivative, the line tangent to the curve pass through the origin. So basically, they want to know how many times does your derivative go through that origin. So I would just take the derivative. So that's going to be 20x to the 4th minus 12x cubed plus 30x. And I would throw that into my y1, get yourself a graph, and I think it kind of looks like this-ish. And you see it goes through once, so your answer is choice A. All right, this question is a little weird, but not hard. It's a bit of a thinking question, and we haven't really dealt with this question all that much. Okay, so it says here that a population grows according to this equation right here, right? Now I want you to notice that we have an E there. So look at what happens. It says this population will approach a limiting value as time goes on. Now you may ask yourself, well, what the heck is a limiting value? I understand. But it says, I want to focus on this, and then I'll explain the limiting value part. It says, as time goes on. Think about this equation. As this t value gets bigger and bigger and bigger and bigger, right? We're going to be plugging that into here. Do you remember what I said about an E graph? What do you know about an E graph? Here we go. Okay, and that's a negative E graph, by the way. So a negative E graph would look like this. What happens as time goes on? Look at what happens. It goes towards 0. So when this says as time goes on, doesn't that mean that this whole portion of your population equation will disappear? Because as time goes on, the graph goes towards 0. So this will become 0. So when they talk about the population approaching a limiting value, 6,000 will be your limiting value. Because as time goes on, this approaches 0. Disappears, your limiting value is 6,000. Okay? Now, Let's read the rest of the equation. So it says during which year, so they want a t-value or an x value, will the population reach half of its limiting value? Well, let's talk about again that I'm just going to write LV for limiting value. My limiting value is 6,000, right? Because again, this approaches 0. So they want to know during what year will the population reach half of that limiting value. So that would be 3,000. So basically, you're going to be setting your P of T equation equal to 3,000 because this is your population and they want to know when it reaches 3,000. Well, this is a calculator question. So if I were you, in my Y1, I would plug in the P of T equation. Okay. In my Y2, I would plug in 3,000. And then from here, I would do second calc intersect. Okay, so second calc intersect. I'm going to give you some time to do that. I will tell you, I'm going to be nice just because we're not in school. These are my X values that I put in for my X min and X max. I went to window because you got some very large numbers here. And then my Y values, I went from a Y min, which was 0, and I put 6,000 as my Y max. So take some time, pause me, put all of this stuff in your Y1, your Y2, fix your window, and then start me up again, okay? All right, so then once you do that and you do second calc intersect, you should get x equals 3.8, okay? And then we're going to round that, and that would round into the 4th year, which would be choice C. I personally think this is a dumb question, but it's really not hard. Again, it's interpreting. So let's read what it says. Okay, it tells you here that this is the graph of the derivative. Okay, and you can read blah, 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 blah. Here, I'm going to read this last part right here. Which of the following best approximates the maximum value of f of x? Well, isn't f of x just the area under this curve? Think about that. Okay, so they are basically just asking for the area under the curve. We got a whole bunch of boxes here, and you know each box, I'm just going to pick this one, is 1 across, and it's 5 high. So each box has an area of 5. So couldn't you just add up all the whole boxes? 5, 5, 5, 5, 5, 5. You get the idea. Add them all up. And then when you get to like a box like this, just approximate. And there's really, trust me, try it. There's only one answer that really makes sense. Take a few minutes, do it. The answer is choice E, as in excellent. It's 110. Okay, like I said, I don't even know why they asked this question. All right, so you are done with sample exam number 1. You survived. So now what you're going to do is we're going to go on to sample exam number 2 because we were having so much fun. I did not give you that handout, but if you look on Google Classroom, it is there now. You can either print it out. If you don't have a printer, not a big deal. Just put it on some loose leaf and keep it neat and organized, and that way you have notes on it. And I'll give you the packet when we get back to school if you want a print out copy.